Hi, DocRevis here with Watch Me Work It. Drawing slightly challenging Lewis structures. Watch me work it. First, let's review some simple rules. If you've seen these rules before, you might want to fast forward. It won't take us long. Draw the individual dot structures. These are what I call the Revis rules of order. Draw the individual dot structure. Focus on the single dots to help you get started. Connect single dots as obvious bonds. This creates the initial connectivity, the sigma framework. Combine any leftover single dots to make lone pairs. Never leave single dots alone unless that is indeed what is intended. Shift lone pairs to satisfy appropriate octets. Make new double bonds as necessary. You don't always have to have double bonds in your structure, by the way. All right. Now, when we talk about the octet rule, remember group 13 is very happy with 6. The others will like to have 8. Group 2 is satisfied if it has 4. It's 2 times 2 equals 4. And here, if it has 2. All right. So what is the Lewis structure of into F2? Ready? Here we go. Watch me work it. So the first thing I want to do is draw out my individual Lewis dots for these. All right, let's see, where's my pen? Oh, there you are. So I want to draw these out first. So I have nitrogen for the individual dots. Nitrogen is going to be my central atom because it has more individual initial opportunity to bond. How do I know that? If I draw nitrogens, group 15, so that's 5 valence electrons. So I draw it around the 4 corners of nitrogen, 1, 2, 3, 4. I highly recommend this method for drawing the initials. So here we see that we have 3 initial opportunities to bond. Since we have 2 of them, why don't I just go ahead and draw the 2 out? 1, 2, 3, 4, 5. 3 opportunities to bond, and I have F. I'm just going to just draw one on either side of this. Stand the reason that they're going to be associated some way like this. Why? Because I know that fluorine is going to be a peripheral atom because it only has 1 opportunity to bond. How do I know that? Fluorine's in group 7A, so it has 7 valence electrons. I draw around the 4 corners, and I'm left with 1 individual opportunity for a single dot to bond. So I'm just going to start to put these together. I'm going to start with these central atoms. I'm going to put these 2 together. I'm on to rule number 2. I'm connecting the obvious. Okay. And so that takes care of that. And I have 1 here. So I'll put 1 on the peripheral there, 1 there, and there. I'm going to put it together now. And you notice I haven't even done any counting of the octet rule 8 yet. Well, you know what? If I follow this, I'm going to be so close to it's only going to be a matter of shifting, okay? Valence electrons, excuse me, not valence electrons, which are valence, but shifting lone pairs to complete the octet rule at best. So if I put all these in just like they are, I count 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. I'm happy. I didn't have to combine any leftover dots. Now I have to shift. Oh boy, I saw this one in 2 rules. That's nice. Move on to the next one. What is the Lewis structure for P2SH2? Boy, this is a little bit more complicated, but I know there's a P is right here. It's in group 15, therefore it's going to have more opportunity to bond than group 16 sulfur. So P is going to be my central atom. How do I know? I can look at it. P, 1, 2, 3, 4, 5. There are 3 individual opportunities to bond. If I draw sulfur, I have 1, 2, 3, 4, 5, 6, only 2. So I surmise that this is going to be my central atom. So I'm going to draw it. So I'm going to go ahead and draw that twice. Okay, 1, 2, 3, 4, 5, 4, 5. Now, I have hydrogens here. So hydrogens are always peripheral atoms. So I'm going to just put them somewhere on the outside. They're not going to be next door. They can't be they can't bond together. That destroys the single dots. So I'm going to take the obvious. This is rule 1. I draw the individuals. Rule 2, take the obvious dots. I'm going to connect here. I'm going to connect here. Now I'm down to a hydrogen, and a sulfur. Notice something about this sulfur. It has 2 individual opportunities to bond. If I put both hydrogens there, I stop the chemistry, right? There's not going to be the rest of the bonding. So I'm going to do the obvious then. I'm going to go ahead and connect this here and put this on the outside of that one and connect here, okay? And that gives me P double bond F. A double bond's a sigma bond and a pi bond, not 2 pi bonds. It's 1 sigma, 1 pi makes a double. And I get an H here, and I get a bent structure for that. I can see that. I get an H here. Don't lose track of any electrons. Check it. Hydrogen has 2, what should be here. And there's 2, 4, 6, 8 around both of the phosphorus. If I don't forget that, put those lone pairs on there. Okay, that was just a matter of didn't remember to write them. 2, 4, 6, 8, 2, 4, 6, 8. I'm happy with that structure as well. On to the next one. What is the Lewis structure of ClAsO2? AS, I'm going to tell you, it's going to be my central atom because it has the highest number of initial. I'm working on rule 1. If you notice, I don't have to go too far in these rules. Yeah. So here we have AS. Then we have chlorine. 1, 2, 3, 4, 5, 6, and 7 chlorine. Then I have oxygen 1, 1, 2, 3, 4, 5, 6, and another oxygen 1, 2, 3, 4, 5, 6. How do I know what 6 is in group 6A, therefore 6 valence electrons. I can add up the total valence electrons here, 6 plus 6 plus 5 plus 7. There you go. So we look at these structures. I'm going to start the individuals. Group 17 is always going to be on the outside, okay? So I'm going to go ahead and assume that this should have been AS, that arsenic is a central atom. And so I have to combine these some way and make this work. So I'm going to go ahead and attach one of these oxygens here, okay? And then I have to think about this a little bit more. I probably should connect another oxygen as well. So I'm just going to go ahead and put this oxygen right here. That looks like that's going to work. It's an ugly line, but it's a line nonetheless. And there's got a single chlorine, so I'm going to go ahead and just connect it here. And then I have a dot here and a dot here. Oh, gee whiz, if I put those 2 together, that will work out just fine. So let's see if we can redraw this where it looks a little neater. Arsenic is sitting in the middle. We have a double bond, which is a single bond, and which is a sigma bond and a pi bond. And so I do that. Then I have this O, which has these 2 lone pairs on it. And then I have a chlorine sitting here with these leftover lone pair. There we go. This molecule has a sigma bond framework, 1, 2, 3 sigma bonds and 1 pi bond to give me that structure. So there you have it. Watch me work it, drawing slightly challenging Lewis structures. That's it.